So, since we're talking about functions, arguments, parameters, scopes, and passing schemes, we should probably talk also about mutable objects and arguments in Python. We should definitely take care because sometimes we think we're changing the object, but we're changing the reference. So let's take a closer look at an example that it can exemplify this, right? So let's define a function like in append twice, because we're going to do some tricky things and appending information twice here. And let's define two parameters for that function. One, a whatever argument, and then we'll have a list here which in theory is empty, okay? And then for that function we're going to do the following. Let's take the list that we received, and then we're going to go there and append the variable that we have for a, and then we'll take that we're going to take that same variable and we're going to append it again in the same list, right? And after that we go there and we return our lists as we have it right here. Well, we don't need the parentheses, but that's fine. Okay, so let's go ahead and call our function. Let's print it out. Let's just put into a variable here. Let's call it results so we can change it a couple of times. And for this, let's call our function append twice here. And for appended twice, what we're going to do is we're going to pass a positional argument that we have for a, and we're going to say, hey, you know that list that we have there? Let's say that list has a given value. Let's say 4 here, okay? And we're going to go there and print it out that result. So yes, print it out result, and I know I have a typo here. Result. There we go. And let's go ahead and print it out to see what happens. So we take that list, which we passed as a keyword argument, in this case here is 4, and then we append 1. So the list now, the first time in the first period is going to be 4, and then after the first append is going to be 1, and then after the second append is going to be 1, 1, right? This is all right. So let's take another example. Now let's see that we have a bigger list with multiple arguments. So let's say 4, 3, 4 and 42 here, and let's run it, and there we go. It seems to be working perfectly fine, right? So what we have here is that 4, 3 and 4 and 42, and we add 1, and then in the second pass here we add 1 again. That's pretty cool, but what would happen, let's say for instance, if we don't pass the keyword itself? Let's just add some cells here. So let's say, instead of working with this here, I'll just say, well, use the default. I have an empty list there, so why not to run this thing here? And then our empty list is, as we can see here, 1, 1, so it's supposed to be fine. And then let's take that same list here, and now let's continue to add that information to our list. And what we have there now is that we have 4 elements here in our 1, because we executed the same line once again, and I'm sorry for that. But then we have 2 and 2 again with the previous list that was being a whole depth for us. And this is not pretty much what we want, right? The thing is, if the binding for our actual list is not supplied, then the list name inside our appended twice function falls back to the array object that lives inside the appended twice dot default, which is the original list that we have there. So for every time we pass one value there, the previous list is going to be appended over and over again. So let's say now here we have another list. So here, let's say if we have 3, There you go. Let's just delete this here. And if we run this here, we'll see that we have the previous list. So just remember, here is supposed to be just one pair. We have two because we run the previous cell multiple times. And then we have 1, 1, 1, and then 2, 2, and then 3, 3. So the previous list is pretty much being altered and not just modified. So how can we mitigate this problem? The thing is, if the list is not provided, we should start a new list and append the value for a new list. So we have to modify our function here. So let's take this function right here, and I don't want to keep running the same cells over again because it's quite polluted. So let's do the following. Let's define our function with a non-value, which means that by default we won't have a list. But if our list, in this case right here, is none, which it will always be in the first case, we're gonna go there and we're gonna start a new list. So we're gonna say that list right here, it's gonna be equals to the list definition, right? And if it's none, we're gonna go there and it just runs over and over again. So we run our list and append the values that we're passing over, right? So, and what we mean by that? We mean that if there is a list being provided, like in this first example that we have right here, so let's run this here. Let's run, and okay, now we have our new appended twice. So what happened if we run a list in which we pass one actual list with an element? It works the same way as before. Why? Because we are passing the keyword as a list here, so the list is not none, so we don't create a new list and we just append it. So far so good, we don't have to worry about it. But now, what happens if we don't pass a list? If we don't pass a list, in this case right here, what we're saying is, take that function, use the parameter positional parameter right here, and since we didn't provide the list, the first if here, this only and first if, it's triggered, and we define a new list which we append the new values. So if we run this, we see 1, 1, and now let's call the same function again, but passing a different value. The thing is, in this function call, we are not passing any list argument as we saw it, so we define a new list. Before, we were simply using the default list that we had it before and we were altering. But now, for every new call for this function, we'll have a new list because of our new if there. So as you can see here, when we call our function, and we can call this again multiple times the way we want it. So let's say here is 21 and then here is 42. So if we call this, for every function call, we're taking the actual signature here to pass a value, and the list value that we have here is defined as none. So we create a list from scratch, which prevents us to modifying one, let's quote here between quotes, one global list. Okay, so thank you and happy coding.